Hello, everyone. We'll continue our discussion on miscellaneous topics. Now, in this slide set, we'll discuss sensors and notifications. Sensors in this video and notifications in the next one. As usual, we have great resources from the Android Developer Guide and related links from there for both these topics. Make sure you take a look at those as well for more details. Uh, okay. So sensors, first of all, yeah. So sensors provide some data from the surrounding, real data from physical surrounding in most cases, and that can be then used to provide uh, a better experience to the user in various different ways. Simple things like when you are making a call, if you hold the phone too close to your ear, um, the device usually disables the screen, right? Otherwise, part of your ear or face touches something and the call may get disconnected or something else may happen. So how does it know that the phone is close to your ear? Or some other body part in that sense, while the phone is in progress? It uses a sensor essentially, okay, in specifically a proximity sensor. So this is how you can enhance the user experience, starting from small things like this to providing better control, like um, maybe playing a game. If you tilt the device, then the some action in the game happens, like that typical maze games that kids play. There is a small marble that has to go in the center. It can be implemented by using the tilt and rotation, etc., and the marble can just go instead of the kid dragging it with the finger. That also can happen, but this gives another kind of experience, a better user experience by some standards. Okay. So there are different types of different categories and different types of sensors that we'll see. But yeah, as the slide says here, the sensors are useful to different types of sensors. I mean, are useful to monitor different device movement, positioning, etc. Um, Ambient environment. Some devices support temperature and humidity sensors as well. Um, you can check for orientation. You can check motion, like uh, how quickly is acceleration, basically how quickly is the device being moved. Again, can be very useful in things like in certain games or some AR, VR apps, um, and other various environment conditions, as we said. Um, Another example can be, a weather application might use the temperature sensor and humidity sensor and calculate things like the dew point or something that is relevant to the user. Um, there can be a compass can be created for some outdoor activities, using the magnetometer and accelerometer to to show the direction the user is going in, etc., um, and so on. Okay, so uh, there are several uses of sensors, and um, we'll see how to use them. So there are three categories of sensors in the world of Android. Motion sensors, they measure the acceleration forces and rotational forces along the three axes. And some examples include the accelerometer, gravity sensor, gyroscope, and rotational vector sensors. Then you have environmental sensors, which give you things like ambient temperature, humidity, etc., illumination, how much light you have on your device, and you can then dim or brighten the screen based on that. And examples here are barometers, photometers, and thermometers. Then finally, the third category is position sensors, which measures the um, like physical position, orientation, etc., of the device. It can also include the magnetometer and get the sense of the like the Earth's magnetic field with respect to the device or the other way around. Right. So Android sensor framework allows the developer to access sensors that are available on the device and also acquire raw sensor data. Um, I think I missed a word there. So, and it provides several classes and interfaces that will use in this slide set. Basically, perform a wide range of tasks that are specific to sensors. Okay. Um, so some examples include, first of all, finding out which sensors are available on the device. You can ask for a list of all the sensors, and then choose or select some based on what the list returns, and handle the ones that are available on the device. Um, for each sensor, you can also get um, a various measurements like the maximum range, um, to so let's say on the device um, the photometric sensor gives a range of 0 to 100, whereas on some other device it gives a range from 0 to 40,000. So it's just a granularity, but then based on the values you can decide when to dim the display and when not to dim the display, etc. You'll also know who is the manufacturer. You can also know what are the power requirements, resolution for each sensor, etc. Then of course you need to acquire the actual data, so that can also happen with these classes, and um, listeners to record the changes, or rather listen to the changes as they are happening. So you have a way of registering and unregistering the sensor events, as we'll see soon. What are the different or other important classes and interfaces in the framework? First of all, you have a sensor manager, which gives you the instance of the sensor service, which is an inbuilt service. You don't have to do anything except grab that service. And then it also provides method for accessing and listing the sensors. So you can create that list of sensors with this class. You can also register and unregister events using this class, and you can acquire orientation information. Okay. This class also provides several constants that are used for reporting accuracy and several other things. Then you have the sensor class itself. The sensor type is, as the name suggests, it's going to be an instance of the specific sensor. It has methods that will let you determine a sensor's capabilities, um, like the range and current value, etc. Um, in addition, um, it can also let you um, um, and it can also let you read some other parameters related to the sensors. Then you have the sensor event, um, which stands for a sensor event object, and it provides the information about an event, like how often the event is happening, um, and similar things. Okay, so you can get the raw sensor data and type from that, and accuracy, and also the timestamp of the event. So when exactly did this event happen? Um, all right. Finally, you have the sensor event listener, which is an interface, not a class. So it provides abstract methods which need to be implemented by the activity or fragment that is going to handle it. So it has two callbacks methods. The first one is on accuracy changed, which tells you if the measure of accuracy has changed, and there are some int constants that specify the accuracy level, basically. And the other one is on sensor changed. So this is when some new sensor event has happened, and in the example we'll see, we'll be listening to this method and reporting the data based on the changes to the sensor event. So earlier we talked about the categories of sensors, and now there are two types of sensors, the hardware and software, basically based on where you are getting the data from. So hardware-based sensors, as the name suggests, are actual physical components built into the device. Um, and the examples here include the accelerometer, um, um, the temperature sensor, etc., etc. So these sensors derive the data directly from those certain environment properties. Um, then you have software-based sensors, which are not physical devices, but they mimic some hardware capabilities. So they can be virtual or um, composite, as in they can report the data based on more than one sensors. Um, and then uh, you have examples like you know um, creating some synthetic information for orientation change, etc., which may combine multiple physical sensors underneath. So these are the two types. On the documentation page, there is a detailed table of all the sensors that are supported by Android, and another table that tells you which API level device supports what kind of sensors. Um, Here we'll see just a few of those, and the link here takes you to the web page for more details. Okay. So you have an accelerometer, which is a hardware sensor, and it gives you motion detection, like shaking the device, tilting the device, etc. You have a gyroscope, which gives you a sense of rotation, again a hardware sensor. If you spin or turn the device, it will tell you that. You have a proximity sensor. That's the one where it tells you how close you are to some other object. Um, so the example that I mentioned, using a phone during a call, right? So using a phone position, if it's too close to your face, you may want to disable certain accidental touches, etc. Then you have the light sensor, which is used for controlling the screen brightness, and we'll see that one in our example pretty soon. And you have orientation, which can be a hardware or a software sensor. The software sensor, as I said, would combine information from a couple other sensors to give you a sense of the position of the device. Yeah. All right, before going further, how can you use emulators with the sensors? Emulators are, of course, virtual devices, and they don't really have these physical um, sensors built into them, but you can do it by going to uh, your virtual device, and then um, actually let me show this. Yeah, so here you can go to this, which opens. Start from here. Um, yeah, so you'll get this. In this, you'll look for virtual sensors. Device position has rotation, okay, or move. You can move it X and Y here and there. As you can see, the device is kind of at an angle right now here, and when you're moving it, it's supposed to be moving with that. You can see the accelerometer change here. It gives you meters per second square. um, in rotation, you can see the gyrometer also change. I'm dragging the device here, and so on. And then you have some additional sensors based on the device. So you have ambient temperature, um, you know, um, in degrees Celsius, as it says here. You have magnetic field, proximity, light, etc. And yeah, will see an example of this light sensor um, being reported, as you can see. the change here is almost instantly reported on our app. Okay, all right. So yeah, I'll skip these two slides because we just saw how to enable these things on the emulator. Since some of you may not have a physical device, that might come useful. Okay. All right, now let's go into the code and see how you can actually find and access these sensors. So first of all, finding available sensors. So on the main activity, we'll have our tag, blah, 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 create an instance for a sensor manager and um, initialize it in the onCreate method. So we get system service and the name of the service is context dot sensor service. It gives you a sensor manager, um, and you can, as you can see, you can obtain it from anywhere. So once you have the sensor manager, you can start calling methods on that, obviously. And here is an example where we ask for all the sensors um, and list them in the log messages. So getting sensor service, getting all device sensors. If you want to ask for a specific one, you can do something like, you can pass it type proximity, type gravity, type gyroscope, type light, etc. The constants that we saw on the table previously. Okay. So I ran this on the device, and this was the output, part of the output that I got. I've removed the timestamp, etc., to focus on just the important part. So it says found Goldfish is the manufacturer, and it's a 3-axis accelerometer. There is a 3-axis gyroscope. There is a 3-axis magnetic field sensor, and so on. Um, so it listed all the sensors on the device. So this is just a simple example of looking for all the sensors. Um, Next, we'll look at how to listen to a specific sensor with the example of the light sensor. So in the same main activity, I'm hiding some things here which we have already used. Um, Now we create a reference for the light sensor. Okay? Its type is sensor, as we discussed in one of the previous slides. And then we are going to have a text view which will simply display the value of the light sensors in big letters, big numbers, a large font, I mean. So we grab the text view as usual. And now we get the sensor light by um, calling the default sensor. So the device may have multiple sensors for the same type. Okay, and you can grab all by using a call like this, get sensor list for that particular type, and then work on each of those. But in most cases, you would simply want to grab just the default sensor and work with that. So yeah, that's what we are doing here. By the way, um, this activity will uh, implement the two, it should have been two, sorry for the typo, two listener methods that we talked about. We'll implement those here, and that's why the implements sensor event listener. Okay. Right, so after grabbing the sensor here, we check if it is null. If it's null, we simply display the error. Um, okay, and we don't want to register that null sensor and try to deal with it and end up in a null pointer exception. In the Now in the on start method, this is more or less the standard procedure. You would register things in on start and unregister them in on stop, um, etc. So you can, of course, you may think of registering it in on create and then removing in on destroy, or registering in on resume and removing in on pause. But it is recommended that you register it in on start and not in on create, on resume, on pause, etc. Why? This ensures that the sensor uses power only when the app is in foreground, and the guide also um, suggests not using on resume on pause pair because you may want to keep the sensor running in the multi-window mode. So remember, in the multi-window mode, if you are in part of, if your activity or app is occupying part of the screen, when you change focus to the other part of the screen, which may have other app, um, you go in on pause, but you are still visible, so you are not in on stop. Your activity is not in the stopped state. Um, but you may still want to keep listening to the sensors, especially if they deal with light, etc. Things that may affect the overall use, or that proximity sensor with the phone call example, right? So for such purposes, you it recommends you unregister it in on stop. So the on start on stop pair instead of the other pairs. Okay. Um, okay, so register listener gets the context from the activity. The sensor, we check it is not null, and then only register it. And we register with the normal delay. So there are different uh, variants, different gradients of delay as well, and normal would usually suffice. Okay, then you have on stop where we simply unregister it. Um, and it is important that you unregister all the listeners that you have registered, so you don't keep on eating up resources that you are no longer actively using. Um, so that's another example of um, showing where on start and on stop or other lifecycle methods can play a role, um, and why it's important to understand those and use those. Okay. All right, now we'll talk about the listener methods where the actual fun is happening. So we register the on sensor changed method, which gets a sensor event. And this is all inside the activity. And we have implemented the listener there, um, the sensor event listener. That's why you get these methods, abstract methods, to be implemented. Um, so the sensor type is the type that the predefined type, as we have seen, that you will get from the sensor event. So sensor event dot sensor, and what is the type of that? Okay, we'll use it, as you can see here. We'll use it to differentiate between different sensors. There is only one listener method, and then you'll have a bunch of switch case or if else things to determine which one. Then here you see the data value, that is the new changed value, and that's why this method was triggered, because it changed. Now certain sensors provide more than one values, like um, the gyroscope accelerometer would give xy coordinate, or which one changed or along which axis, etc. So each sensor event has an array of values, not a single value. But the light sensor that we are using here, just one value suffices, so it will always be values 0, and that's the one we are grabbing here. To know, I mean, you'll have to look into the documentation of each specific sensor to know which one is relevant, which one is, or what kind of values it's going to return. Yeah, the next part is fairly straightforward. Switch on the sensor type, which we already grabbed, and then case for each sensor. If you have multiple, we had only registered the light sensor here, so not a big deal. Um, and then once you are in that switch case, you can do whatever you want with the data. In this case, we'll simply display the value on the text view. Okay, so this method is called, the on sensor changed method is called when the sensor reports a new data and passes the sensor event to this method. Okay. This method, as you can see, contains information about the new sensor data, specifically the sensor um, variable or field, which gives you the generated event, and then values, which return an array of values. Um, okay. Finally, we have the accuracy change listener. which we are not using here, um, you know, because we don't, we're not worried about the change in accuracy. But these are the different levels: sensor status accuracy low, medium, high, unreliable, and no contact. So for certain applications, you can look into those specific levels of accuracy, and your app can respond accordingly. So this is an abstract method of the interface, so it must be implemented. But in this example, we'll leave it blank because we don't really use it. All right, so that's all about sensors, and we already saw the sample, but here's a quick view again. As you change the light luminosity value, you see the values reflected here exactly as they are, with two decimal points accuracy instead of one here. Yeah, since um, it's an emulator, there isn't anything else happening. But on a physical device, you can change other things as well, and there could be listeners to show or reflect those changes. Okay, all right. So we'll stop here, and we'll talk about notifications in the next video. Thank you.